Question number 33. Very easy question. He gave you the density and the mass, and he wanted to know how much oil did the metal displace, which is simply wanted to know the volume of the aluminium. So we all know that density is equal to the mass over volume. So the volume is simply equal to the mass over the density, which is equal to the mass 775 over the density, which is 2.7. So the result will be 287 centimeter cube. So why he give you the density of the oil? He just gave you the density of the oil to make a ratio between the density of the aluminium and the density of the oil, to make sure that the total piece or the whole piece of the aluminium will be submerged in water. So you will calculate the total volume of the piece. I hope you understand this. Question number 34. He wants to know the apparent mass or the apparent weight. Let me see that. So the apparent weight is simply is equal to the actual weight minus the buoyant force. The actual weight is mg, or which the weight, the mass in the air, minus the buoyant force. So mg minus the buoyant force, we all know it is a simple rule. The density times the gravity times the volume. Okay, so we will need the mass. He gave us in the givens. The gravity is 9.8, and the density he gave us in the questions. The gravity was 9.8. The volume, so he didn't give us in the givens the volume, so we will calculate the volume. Simply, the volume is equal to the mass over the density. So the volume will be 775 over 2.7. So the mass is simply 287 87 centimeter cube. So the second step, we will substitute in this rule. So the apparent weight is the mass, which is 775 times the gravity, which is 10, minus the density of the oil, which is 0.65 times the gravity, which is 10, times the volume. So the result will be this number. So this is the apparent weight. But in the question, he wanted to know the mass with which the balance will read. So we will divide this number over 10, which is the gravity. So the mass, which is the balance will read, not the actual mass, will be the 588 grams. You may ask yourself why we didn't convert from grams to kilograms. He gave us the mass in the grams, not in the kilograms. So all the numbers in the questions in gram and centimeter cube, so all the units are suitable for each other. So this will make the question harder for you, and will not minify it you in any way. If you do this, or you convert it from grams to kilograms, the result will be true, but you will make it harder for you. Question number 35. In this case, the weight is simply equal to, the normal case is equal to the buoyant force. So the weight is the mass of the wood times the gravity. Let us M1 is the mass of the wood, equal to M2, which is the mass of the oil, which is displaced by the wood. G and G cancel, we will find M1 is equal to M2. He gave us the givens. M1, which is the mass of the wood, is equal to 1,500 grams, which is equal to M2 PV. M is PV, the density, or ρ V, the density times the volume. The density of the oil. So the density of the oil is 0.5. Sorry, the density of the oil is 0.75 times the volume. So the volume is simply equal to 2,000 centimeter cube. You will solve it as an equation, normal equation. You will divide 1,500 over 0.75, so the result will be 2,000 centimeter cube. Question number 36. He wants to know what volume of the water is displaced by a submerged 2 kilogram cylinder made of solid aluminum. So the volume of the water displaced by the cylinder will be equal to the volume of the aluminum. So we will calculate the volume of the aluminum. The volume of the aluminum is simply equal to M over B. The mass is 2 kilogram over the density. This is ρ, not P. It's called ρ. Okay. A Greek letter. The density of the aluminium is simply 2.7, which is equal to 7.4 times 10 power negative 4 meter cube. Cube. So the answer is A. Oh, this question. I think this question is hard. A ping pong ball has an average density 0.084 gram per centimeter cube, and the diameter the radius diameter is 3.8. He wants to know the force that required to keep the ball is submerged in water. Consider this shape, the ball. Okay, consider this is a ball. It is a rectangle, but anyway. This is a free body diagram for the ball. So, mg plus the force that's required to keep the ball is completely submerged in underwater, minus the buoyant force will be equal to 0. So, the force which is required will be equal to Fb minus mg. The buoyant force, we all know, is simply the basic rule. The density times the gravity times the volume minus mg. He didn't give us the volume, so we will calculate the volume first. First, we have to know the radius. The radius is the diameter over 2. Which is 3.8 over 2. Which is simply 1.9 centimeter is equal to 0.019 meter. So the volume of the ball is simply the basic rule we all know, 4 over 3 times by times the radius power 3. The radius 0.019 power 3. By using the calculator, the volume will be 2.87 874 times 10 power negative 5 times 10 power negative 5 meter cube. So this is the volume, and we have to know the mass to know mg. We know the volume and we know the density, but the density in the unit of gram per centimeter cube, so we will convert it to gram per meter cube. So the density is equal to 0.084 times 100 power 3 100 power 3 over 1000, which is equal to 84 kilogram per meter cube. So this is the density. Here we have the volume and the density, so we can simply calculate the mass. The mass is simply the density times the volume. So we have the density is 84 times the volume, which we just calculate, 2.874 times 10 power negative 5 . So the mass will be 2.4 times 10 power negative 3 kilogram. So this is the mass. Let us substitute in this rule. In this rule. So F will be the density of the ball, which is 0. The density of the water, which is 1000, times the gravity times the volume, times 10 power negative 3 times 9.8. We just substitute in this rule, so the answer will be 0.258 Newton. I hope you understand this question. Question number 38. We have a rule, I hope you know it. If you don't know this rule, I will right now. I highly recommend you to see the videos in my description box. We'll explain where this rule came from. X okay, to make you see the photo. X over H equal to the density of the liquid, density of the object over density of the liquid. So if you want to calculate X, which is the part which is immersed in water, you will make this x is equal to the density of the object times times h over the density of the liquid, which is P2. So the density of the object is 0.78 times 10 over 1. So 1 is the density of the water, so it will be equal to 7.8 centimeter. So the part which is immersed in water is 7.8 centimeter. But he wanted to know what height of the block will float above the surface. The total height is 10. So the part which is above the surface will be 10 minus x, will be 10 minus 7.8, which will be equal to 0.2 centimeter. I hope you understand this. Question number 39. Yes, he wanted to know, okay, however, below the water surface is about bottom. Okay, FB of the buoyant force is simply equal to mg. So the density of the liquid, P1, times the gravity times the volume will be equal to the density of the object multiplied by the gravity times the volume. We all know the volume is simply the area times the height, so we can simply write the volume in this way: the area times the height. In the question, he wanted to know h. Of the thing we will do is substituting in the rule. The mg is simply the mass is 60 kilogram times 9.8 will be equal to, the density of the water multiplied by the gravity, which is 9.8, multiplied by the area of the base, which is 4, multiplied by h. So you will solve this and by the calculator or manually. Anyway, you will find that h is equal to 0.015 meter. So the answer is B. The last question in this video, question 40. First, I hope you read this question very carefully. We have two cases. The first case, only the boat is above the surface of water, no fishermen. So in this case, the height under the water will be, let us calculate it. Mg is equal to the same rule, the density times the gravity times the area of the base times h. So we'll substitute in it in the same way. 1000 density of water multiplied by 9.8 times the area of the base, which is 4, multiplied by h. So h will be again 0.015 meter. This is in the first case. In the second case, we will use the same rule, but after add the mass of the fisherman to the mass of the boat. So the same rule, mg equal to the density times the gravity times the area times the height. So m is in this case 360 kilograms multiplied by 9.8 will be equal to the density of the water, which is 1000 times 9.8 times the area of the base multiplied by h. So h in this case will be 0.09 meter. But wait, you will not choose the answer is B. No. In the question, he wants to know how much lower will the boat ride in water. So you will subtract h1 minus h2, or h2 minus h1. Sorry, this is h1, h2, and this is h1. You will subtract h2 minus h1, h2 minus, because he wants to know how much lower, minus 0.05. So the answer will be 0.075 meter. So the answer is C.